Morning guys. Next topic. Now we are going to discuss about a typical embedded system. Typical embedded system is just simply like what are the components available in embedded systems and how the components are going to be working and supporting the embedded systems. Usually, embedded system contains only single chip controller which act as a brain of a embedded system. So now we are going to learn which are having a availability or capability to act as a single chip controller or else brain of an embedded system. So there may be a chance of microprocessors that we can use as a brain of an embedded system, or microcontrollers, yes, we can use as a brain of an embedded system. Next one is FPGA, field programmable gate arrays, we can use it as a brain. And last one is ASICs, application specific integrated circuits, we can use as a core of an embedded system. Now we are going to learn how these will support for core of the embedded system and how the generations will support for implementing an embedded system. So this is the basic raw structure of embedded system. So first I need one core, system core. This is my master brain of an embedded system. So these are the remaining parts are just like our human body, rest of the organs. So first one is memory. First one is memory. So which will use to implement any task, whether it needed to send any one of the information to this brain or the action which is performed by this brain has to be implementation. Both the tasks has to be implemented by using the memory itself only. Here we are going to learn memory is two types. First one is ROM, read only memory, and next one is RAM, random access memory. So RAM is only for the purpose of accessing the information from core or from the IO devices or the external input devices, and ROM is only for storage. It's just like our hard disk, HDD. And next one is communication interfaces, means which will create interfaces, nothing but just like a bridge, which will create an interface in between embedded system with any one of the system, or core to memory, or core to input devices or output ports. Whenever you need to create any one of the bridge to send or receive information, then you need to use communication interfaces. And the next one is output ports. For example, I have given one task to this particular core of the system. It has been implemented and then executed. Then the executed output has to be displayed, or it has to go for some next component input. Then we need actuators. We already know that actuators will not perform any action. Whichever the input that it has to be received by the actuators, the same input has to be displayed or executed by using actuators. Next one is input ports. Input ports is nothing but I need to send input information. Either it may be in terms of signals, or it may be in terms of data, or it may be in terms of digital also. When I need to send any one of the input signal, then I used to choose sensors. It will accept the input, at the same time it will perform some actions, and then the output of this particular sensor has to be received by this system core. And the last one is other supporting ICs or subsystems. So why we need subsystem? Whenever we are performing any action in between sensors and actuators. Means, for example, I have taken one input for sensor. Let's my input is X1. I have given to sensor. Then sensor has to send this X1 input to core of the system. First question is how it will communicate with the core of the system. Okay. Next, the action performed by this core is executed. Once it is executed, then it has to send the information to actuator to display the output. Again, my question is how it will send information from core to actuators. There, the vital role of subsystem will take place. Means, in this subsystem, we have several components. Those components will act as a communicating path in between sensors to core, at the same time core to actuators. Okay. So let's have a deep discussion about a core of embedded system. So as we already know about of embedded systems, what are the core supporting embedded systems? So basically, core can be implemented on based on domain specific or application specific. We usually build an embedded system based on either it may be domain specific embedded system or it may be application specific embedded system. Any one of the purpose, whether it may be domain or it may be application specific purpose, we need brain, or else in terms of embedded system we need core. For that particular core, you can use general purpose or domain specific processors or application specific integrated circuits like ASICs or programmable logic devices and COTS, commercial off-the-shelf components. So how we are going to utilize these R4 components? Have a look. So in general purpose and domain specific process, we are going to use microprocessors, microcontrollers, and the difference between microprocessors and microcontrollers. Have a look with the microprocessors. What is microprocessor? Microprocessor is a silicon chip representing with CPU. So it's a pure CPU, means central processing unit, which will perform all the arithmetic and logical unit and having a control unit with working registers. So why we need ALU, CU and WR? Have a look. So I have one CPU, central processing unit. So it has to perform all the arithmetic and logical operations, whichever the tasks that we are giving to the CPU, that it can be calculated by using ALU only. And why we need CU, control unit, to control the data from one place to another place, either it may be in terms of transmission or it may be in terms of receiving also. So from one register to another register. When we are transferring a data or receiving a data, control unit will take care. And last one is working registers. Means whenever you are performing any one of the action or task, that particular task's input and output has to be stored in working registers only. For example, I have 1, 2, 3, 4, 5, 6 lines program. When I am executing or compiling this particular program, when the first statement is executed, that particular first statement's output has to be stored in working register 1. And then second statement will execute. Once the second statement will execute, then that will be stored in working register 2. For example, working register 2 is not available. Then we have WR1, working register 1. Register means register means this is location number 1, location number 2, 3, 4, 5, 6. So we have only one register, working register 1. So first statement's output is going to be stored in first location. Once the second statement is executed, then this information is shifted to second location, and then this will becomes statement 2 output. And once the third statement is executed, then 1 will be shifted to here, and 1 if it is 0, and this one is also 0, let it be. So once 5, 6 statements are executed, then this 1 will come to here and 00. So now my register consisting of value like this one. This particular program's entire output is this one. Means each and every statement wise input and output has to be stored in working registers. And next one, basically microprocessor is a dependent unit, means it is having only brain, means it can think. But once thinking process is completed, then it need to perform any action. For this particular purpose, it need input and output devices, IO devices. We used to call it up as. Means brain is nothing but this is my core. Once I have a core, here I am using core as microprocessor. So once I have a core means it can think or it can execute or it can perform any one of the action by using ALUs, arithmetic and logical unit. But once the process has to be executed by using ALU, then it need to display the output of ALU, then it needs IO devices. Manually, we need to create the support of IO devices to core of the embedded system. Then only it can perform any one else. These IO devices may be like memory and timer units and interrupt controllers and any one of the external device which will give the support to our microprocessor is any device. Let's have a look of generations of microprocessors. So Intel 4004 is the first microprocessor which will implemented for 4-bit. So this is 4-bit microprocessor. In 1971, the 4004 is the first microprocessor. It is having only 4-bit capability and having 128-bit memory. 128-bit memory only. So nowadays we are calling 2 GB, 3 GB, 64 GB internal hard disk. Na? The same memory initial days 128-bit memory only it is having. After getting few months and few years, Intel 4040, the next generation of 400 will come. It is having the same 4-bit memory, 4-bit capability, but it is having a support of instruction sets. So after getting few more years, Intel giving a drastic change in microprocessor fabrication. It will generate an 8-bit microprocessor where the revolution will start. So once they are having 8-bit support, then the miracles will take place. Within 2 years, 8080 is introduced with 8-bit capability, and with this instruction set support plus and memory has been increased to 512 bits. Here we are using only 128-bit. So here also you are using only 128-bit. But once it exceeds the time, it is increased up to 512 bits. So in 1976, the first microprocessors which will support for interfacing, 8085 has been introduced. And then 8086 came, where the microprocessor generations, implementations, vital role will take place with Intel 8086. What you are already learned in your microprocessors and microcontrollers. But once 8086 means it is having a capability of 16-bit, and the memory also increased to 1024 in terms of bytes. So once 8086 will came, they tried with 8088, but while comparing with the 8086, 8088 performance is not up to the mark. Then immediately they just joined 8086 plus same 8086 one more processor. Usually they used to call it up as 8086, means they are using two number of 8086 in a single processor. That's what it is, 80286. And then they'll add one more 8086. So then they'll get 80386. Next, they'll add one more. Next, they'll add one more. So finally, we have 58086, 80586. 5. In terms of technical knowledge, we used to call it as Pentium, Penta. Penta means 5, means 80586 is usually called as Pentium processor, means it is consisting of 5 number of 8086 processors. The next one is Pentium 2, Pentium 3, Pentium 4, means once P1 is nothing but only Pentium having 5 number of 8086 processors. If it is comes to P2 having 2 number of Pentium 1 processors, means which is consisting of 10 number of 8086 processors. And the next one is P3, Pentium 3, having 3 number of Pentium 1 processors. That is nothing but 15 number of 8086 processors. And the next one will comes to P4, Pentium 4, having 4 number of P1. That is nothing but 20 number of 8086 processors. Once P4, 2001, it has been introduced, having 4 number of Pentiums. And the next one is dual core. Dual core means I used to shortcut as DC, dual core, having two number of P4s. Means P4 consisting of 20 number of 8086 processors, means it is having 20 into 20, 20 plus 20 of 8086, means 40 8086 processors are going to be using in DC. DC means dual core. Next one is core 2 dual. Core 2 dual, CD, shortcut, having these two number of dual cores they are using. Core 2 dual means having two number of dual cores we are using over here. Core 2 dual. So means I am using two number of dual cores I am using. Next, I3, I5 and I7. So for example, I need I3 processor means I am using 3. If it is I5 processor, I am using 5. If it is I7 processor, I am using 7 number of cores. Means once the generation is going to be increasing, then the number of cores that we are using in one particular course is going to be increasing, because the usage means supporting applications. Are going to be increasing day by day. Our human beings' needs and necessity are going to be increasing. Means it has to satisfy still more and more updated versions of all OS operating systems, all types of applications, by using our embedded system. For that particular purpose only, we are improving the capability of all microprocessors. Next, second terminal or else component that we are using can be having a possibility to use as core is microcontrollers. So what is a microcontroller and what is the difference between microprocessor and microcontroller? First, have a description about of microcontrollers. It is highly integrated chip. So before we have learned about of microprocessors, and microprocessor is a single chip, and but in microcontroller you are using highly integrated chip, means you need to integrate with some other components along with the core. For example, if it is a microprocessor, I have CPU, which is consisting of ALU and control unit and working registers. These are the components are available with our microprocessors. But now we are coming to microcontrollers along with the CPU, means once the CPU having means we already have ALUs, control registers and working registers. So along with the CPU, I need memory. Next, general purpose registers. Next, on-chip memory, timing devices, control units and dedicated I/O ports. These are all the terms or all the components are integrated along with the CPU. So RAM means this is our memory, and general purpose registers plus control unit plus all I/O devices. When I am integrating all the components in one single chip, that I used to call it up as microcontroller. If it is a microprocessor, I have only CPU. Rest of all, I need to collect manually and I need to create the interface in between all the components to the CPU. But if it is a microcontroller, we don't want to create any interface. externally for implementing any one of the tasks. When you are manufacturing any one of the microcontroller, that is inbuilt, when we are manufacturing inbuilt, we have to take the support of all the components along with CPU. So when it is coming to microprocessor generations, the first microprocessor is 4004, which is having a capability of 4-bit microprocessor, and it is having 128 bits of memory. Same as this is for microprocessors. If it is a microcontroller, they are using TMS 1000. TMS 1000 is the world's first microcontroller which can be implemented with Texas instrumentation. It is also having same 4-bit microcontroller with 128-bit memory. That's what exactly 4004 and 4040. Along with some amount of RAM is improving. So for example, it is having a RAM of 32-bit LED. So here along with 32, they will add one more 32-bit RAM. Means along with the microprocessors first generation 4004, they are adding some more RAM to perform the actions and the tasks a bit more faster than microprocessors. And next one, after completion of first generation 4004 and 4008, the first microcontroller is TMS 1000. Once it is generated, then Intel introduced into microcontrollers generations. Then the Intel generated microcontroller series 48, MCS 48. MCS 48 means microcontroller series 48. So for examples, 8038, 8039, 8040, 8048, 8049 and 8050. What about this HL, 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 this is only H, H, and I think this is AH. These are the registers, okay? So after completion of MCS 48, the first one is TMS 1000 and next one is microcontroller series 48 and the next one will come MCS 51. MCS 51, microcontroller series of 51, MCS 51. So in this MCS 51, you have 8051 microcontroller, where it will gives the drastic growth and support to all the applications using microcontroller. With this only the first ASIC is introduced, application specific integrated circuits. Up to that extent also ASICs are there, but they are not going to giving support to more number of applications. But once MCS 51 is introduced, in that series 8051 will give the drastic support to implement the embedded systems or implement the ASICs for several applications. So up to this extent, why TMS 1000 and MCS 48 will not support for all? What are the advantages that we have for 8051R? The first one is very low price. That's the first criteria that we are going to implement when in terms of hardware. Next one is wide availability, means you can that 8051 can be available in any one of the small electronic gadget shops also. And the most important thing is memory efficient instruction set. Means, so for example, I have 4-bit instruction set. or else I just need to implement a small application using microcontroller. Then I'm going to implement with the help of 8051, and 8051 is my core. With the 8051, this 4-bit support is enough for me. Then this 8051 will take working registers with 4-bit only. It won't take 8-bit or 16-bit and to waste the memory also, because it's an ASIC, application specific integrated circuit. Whenever you need to implement any one particular application, then you can use microcontrollers. For example, I am using one application with 8-bit. I need to implement one application. For that particular application, I need support of 8-bit.